Welcome back to All This Math. This is Professor Parker. Please make sure you subscribe to the channel, subscribe to the All This Math YouTube channel. Please like and share some videos, drop a comment down below. You know what I mean? Habarigani. It's the second day of Kwanzaa. And the Nguzo Saba, this is Kujichagulia. Kujichagulia, of course, means self-determination, right? When we are determined, we are, you're not supposed to define a term by using the same term, right? So I don't want to do that. So if I define, or if I explain self-determination, let me say this. Let me say it basically means that you decide, right, for yourself. You decide the way in which you're going to do things and the way in which you're going to commit to an action, right? So how does this relate to math, right? This relates to math in this sense, right? I'm gonna demonstrate this. We can name any method or any protocol or process or algorithm within mathematics, algebra, pre-cal, geometry, whatever, anything we want to name it. We can be self-determined as black people, right? We can do that. Anything that's in a textbook, any name that's been given to a mathematical process, somebody or some group of people was self-determined to call it that. There's nothing stopping us from doing the same thing. So in this here second day of Kwanzaa, I'm going to apply self-determination or Kujichagulia in terms of algebra and how we factor a quadratic trinomial. This is called a trinomial because it's got three terms. The prefix tri means three. 1, 2, 3, three terms. And why is it quadratic? It's quadratic because the largest exponent you see out of these three terms is a 2. Right? The largest exponent you see is a 2, so that makes it quadratic. There's other reasons that it's quadratic, but that's a quick and dirty and good explanation. While I'm at it, I also want to shout out Xavier University. Well, some people call it Xavier University. I call it Xavier University. Down in New Orleans, down in NOLA. Another HBCU down there is Dillard. There might be another HBCU down there. I don't think it is. If it is, forgive me. No disrespect. I need to do my research. But I think it might be just Xavier or Xavier and Dillard University, right? Down there in New Orleans, in Louisiana, where in 1811, German Coast Slave Rebellion took place, led by Charles de Landé and a bunch of other brothers and sisters, right? Make sure you do your research on that, right? Don't be one of these people talking about, I'm not my ancestors because you didn't do your research. You don't know that your ancestors been fighting forever since day one, right? So all over the country too, but I just mentioned that because that took place in New Orleans, and that's the same place where this college on my hoodie is located at, down in New Orleans. All right, so Kwanzaa math, Kujichagulia, we about to factor this. Now, what I do is I call the method that I use, I'm self-determined, I call it the Malcolm X method. Let me break it down. Let me show you why I call it the Malcolm X method. You might go on the internet or you might have a teacher that might show you a way to factor a quadratic trinomial, especially when the lead coefficient, this number right here, is not a 1. When this number is not a 1, like in this case it's an 8, so if it was a 7, a 10, a 5, or 4, that makes it more complicated. That makes it more complicated. If this number ain't a 1, that's going to make the process more complicated. Cool. You might go online, somebody might call it the diamond method, or I don't know, some type of box method. I'm going to call it the Malcolm X method. Why? Because I want to. Because I like evoking the ancestors. That's what I like doing. Right? And it makes sense. Because look, this one thing you can do, right? You draw an X on your paper. And actually, before that, let me write this down. Let me say Malcolm X method. Right? So boom, we got Malcolm X method. Now, first thing we're going to do is we're going to do AC. Now, what does AC mean? A represents the lead coefficient, which in this case is 8. C represents the constant at the end. B is the coefficient of the linear term. So you see how the numbers go in alphabetical order? A, B, C. A, B, C. A, B, C. Right? So this means A times C. So the first step in the process is to multiply the term in the place of A by the term in the place of C. So that's going to be 8 times negative 9. And if we know our multiplication facts, we know that 8 times negative 9 is negative 72. So we got negative 72. Now I'm going to take this negative 72 and I'm going to throw it up here in the top of the X, right? The top of the Malcolm X. All right. Now another thing, with AC, since we're doing hystematics, right? We're using black history to teach mathematics, and we're using mathematics to teach black history anyway. AC could stand for the initials of Alexander Crummell. Alexander Crummell. Alexander Crummell is a person that you should be familiar with. Alexander Crummell was one of the teachers of the late W.E.B. Du Bois. Du Bois, in his most famous work, probably his most famous work, Souls of Black Folk, dedicated a chapter or an essay to Alexander Crummell, one of his teachers. Alexander Crummell, when he was a youngin', he ran with Henry Highland Garnett. If you're from Baltimore, there's a park named after Henry Highland Garnett in Baltimore. Henry Highland Garnett, during the 19th century, said, "Let your motto be resistance." He issued a rallying cry and a speech to enslaved Africans in his nation to rise up and rebel against slavery. Douglas had a different idea. No disrespect to Douglas, but he had a different idea at the time. All right? But do your research on Henry Highland Garnett. Also do your research on Frederick Douglass. Also do your research on Alexander Crummell. Alexander Crummell. And again, W.E.B. Du Bois, do your research on him too. He wrote an essay in the Souls of Black Folk about Alexander Crummell. All right? So this is the first part, right? So then we got to identify what B is. B is positive 14. B is positive 14. And what do we do with the 14? We're going to put the 14 in the bottom of the X. Right there. So we got a negative 72 and a positive 14. Now we need numbers that go here and here. All right, so I'm gonna put some blank spaces. I need a number here and a number here. Now what those numbers are two magic numbers. I call them two magic numbers. They are two numbers that are factors of negative 72 that also add up to 14. Factors of negative 72 that also add up to 14. If you're not as well versed and not as fluent with factors of numbers, cool. That means you're going to have to just write them down. So what I do is I start with the factors of my number, my negative 72, or my product of A and C. And I just say like this. I say, okay, well, 1 times 72. And I don't worry about the negative sign, right? Not at first. I deal with that later. So 1 is 72. And I say, well, 1 plus 72 will not give me 14. So I know that's not going to work. Then I go to the number 2, because I know 2 is a factor of 72, because 72 is an even number, and 2 is a factor of any even number. So I say, well, 2 and 36, because I'm fluent with number sense, and I'm fluent with multiplication facts. So I know 2 times 36 is 72, but 2 plus 36 is not going to give me 14. So these two ain't going to work. Then I go to 3. I say, well, is 3 a factor of 72? Yeah, 3 is a factor of 72. I just know that because, but you could just experiment and do 72 divided by 3 to figure out if you get a whole number quotient for that. But 3 of 72 is 3 times 24. So then we say, okay, well, is 3 plus 24 equal to 14? No, it's not. So this pair not good neither. Then we go to 4. Now 4 got to be a factor. You know why? Because 2 is a factor. And if I double the 2, I get 4. And I take half of the 36, I get 18. That's another math tactic. I could double one number and take half of the other number, and both of those resulting numbers will still be factors of the original number we was talking about. So just like 2 times 36 is 72, 4 times 18 is 72. And this works for any numbers, right? If you could double one of the numbers and take half of the other number, those two new numbers will also be factors of the number that you started dealing with in the first place. So now, what's 4 plus 18? It's not 14. But hold up, though. Wait a second. Remember, this is actually a negative 72. So that means one of these numbers got to be negative. So if one of these numbers is negative, right? Because if you multiply negative times a positive, you get a negative, right? Remember I said before, I ain't worried about the negative numbers until later. When we add these two, if I make one of them negative, can I end up with positive 14? I can. What if I make this negative 4? What's negative 4 plus 18? Positive 14. Negative 4 plus 18, positive 14. So we're using the Malcolm X method. We're talking about other black people from history, Alexander Crummell. Oh, I forgot to mention. Oh, hold up. Let me put you on. Watch this. Boaz Cayman. This was the site in Haiti, or Saint Domingue, as it was known before, it was called Haiti, right? Where the last meeting was held before the Haitian Revolution kicked off in 1791 in August. A spot called Bois Cayman. I think that's the pronunciation of it. So the B matches up. So when you think of B, right, when you factor in a quadratic trinomial, what your B value is, 14, think of Bois Cayman. Bois Cayman. Think of that. Make the connection. All right? So our two numbers are -4 and 18. So we're going to put those in here. Again, Malcolm X method. Malcolm X method, right? So those are two numbers. Now what we're going to do with those two numbers? What we're going to do with those two numbers is we're going to take this expression and basically stretch it out. We're going to stretch it out. All right? We're going to stretch it out. Right? So we're going to keep the 8x squared the same. But this 14x, we're going to do something with this 14x. This 14x is going to become -4x plus 18x. -4x plus 18x. And then the -9 will stay the same. This stay the same, and this stay the same. This stay the same, and this stay the same. The 8x squared is still going to be there. The -9 is still going to be there. This is going to be different. Isn't this equivalent to 14x? All I did was rewrite this by making it longer. I took 3 terms and turned it into 4 terms. Stretched it out, basically. So now it's -4x and 18x. Now, why did I do that, though? I want you to always know why you're doing stuff when you do algebra. I'm doing it because now I got 4 terms, so now I can use a method called factoring by grouping. Factoring by grouping. And in my groups, I got to have an equal number of terms. I can't have 2 terms in one group and 1 term in another group. I don't want that. I want 2 and 2. I want pairs. Pairs, right? So I got 8x squared minus 4x plus 18x minus 9. That's what I got, right? So now my first group, and I need to know how to find the greatest common factor. So if you know how to factor and find the greatest common factor, you should be straight. If you don't, check my playlist on factoring out the greatest common factor so you can know how to do this. Or check my playlist on factoring by grouping so you can know how to do this. All right? So now, the GCF of these two terms is, let me see something. Oh, yeah. I did it differently I set it up differently when I did it on paper, but we're going to do the same answer. It's all good. So the GCF is going to be 4x. 4x, right? And then in the parentheses, you divide each of these two terms by 4x. So 8x squared divided by 4x, that's going to be 2x. So you put the 2x right here in the first slide. Then you're going to do -4x divided by 4x. -4x divided by +4x is equal to -1, right? Make sure my mic was still on. -1. So that first part, these first two terms have been factored into this. Then we go over here to the plus 18x minus 9. Now, what's the greatest common factor of positive 18x and -9? We're going to say positive 9. So we're going to do plus 9 and then parentheses, just like we did over here. Then we're going to do 18x divided by 9, which is going to be 2x. Then we're going to do -9 divided by 9, which is going to be -1. Excuse me. Now, again, this is called the Malcolm X method. I call it the Malcolm X method because we start out with an X, and we use that to organize our numbers that we're going to deal with. Our -72, Alexander Crummell, product of these two numbers. The B term, Bois Cayman, the location in Haiti where the meeting right before the Haitian Revolution kicked off. Dessalines, Toussaint, everybody, right? And then we got the two numbers we need in order to stretch this out. Make it 8x squared minus 4x plus 18x minus 9. Now, again, back to Malcolm X. We talk about some of Malcolm's history. After Malcolm leaves the Nation of Islam, near the end of his life, he starts 2 organizations where he's a member of both. So that makes him the common factor. Malcolm is the common factor. He starts the Muslim Mosque Incorporated, which is for any Muslim person. He also starts the OAAU, the Organization for Afro-American Unity. He starts 2 organizations, but he is the common factor because he is a member of both and he starts both. All right, so like 2x minus 1. Malcolm X with the Muslim Mosque Incorporated, Malcolm X with the OAAU. So how do we rewrite this as a final answer? We take the common factor, in this case 2x minus 1, and then we put these two together. They become friends. 4x plus 9. This is the final answer. Quantity 2x minus 1 times the quantity 4x plus 9. This is self-determination. It don't matter. Like, whatever textbook your child is using in school, they're not going to call it that. So what? You can call it that. I'm calling it this, right? It's the same method, right? The same steps that you might see under a different name, right? But you get a history lesson baked in, right? You get a history lesson baked in at the same time that you're learning the algebra, right? And the history lesson is going to help your child or you, as the parent or the adult, it's going to help you remember what the steps are, right? Because now there's a story attached to it, and now it's not as abstract. Because that's one of the challenges with mathematics education and algebra is that oftentimes it's very abstract, so it's difficult to catch the rhythm of it. There's a rhythm to math, there's a rhythm to algebra, there's a rhythm to geometry, pre-calculus, calculus, but you got to catch the rhythm. If you can't catch the beat, essentially, it's going to be more difficult to do. One of the ways I think we can catch the beat is by incorporating history, our own history, into it. That's why I call this the Malcolm X method. And I determined that that was appropriate. So this is it. This is the factored form of 8x squared plus 14x minus 9. It's broken down into two linear. This is quadratic. When you factor, the purpose of factoring is to break the expression down into linear terms, right? If they start out quadratic, right? 2x minus 1. The biggest exponent I don't see is a 1. Because we got, and it only applies to the variables. We got x with no exponent. There's no exponent, there's an invisible 1 there. This is x to the first power. This is x to the first power. Right? So that means this is linear, this is linear. So now if this was in an equation, and it said equals 0, we would take each of these and set up a simple two-step equation. 2x minus 1 equals 0, solve for x. 4x plus 9 equals 0, solve for x. That's what I would do. All right? But anyway, happy Kwanzaa, Kujichagulia, self-determination, right? Don't limit yourself. You can call any mathematical method anything you want to call it, right? You can call this the Malcolm X method. You can call it something else, right? I know a sister down in Atlanta. She teaches at a school down there. I think they shout out to her, the Colombo Institute. I think her name is Tashia, and she calls the Pythagorean theorem. What she call it? The Ptah-Heru method or the Ptah-Heru theorem. I love it. I'm a fan. I was gonna do a video on that, but I decided I wanted to rock out with, Brother Malcolm. I wanted to, evoke him. But I was gonna do an example using the Ptah-Heru theorem, right? With the ladder leaning up against a wall of a building, and calculate some things. You know what I'm saying? I was gonna do that, but I'll probably do another video with that, like at another time. You know what I'm saying? But yeah. Practice factoring quadratic trinomials. Use the Malcolm X method. Don't use the Malcolm X method. Whatever. Just as long as you can factor quadratic trinomials. Whatever works. You know what I'm saying? All right. I will see y'all on day 3 of Kwanzaa. Peace.